going to talk about join process and max score, or in memory join, you can say max score in memory join. We don't have sorted data, we have unsorted data, and we are going to unsorted join process. Okay, so what have we have is like we have an input data and we have to join, and then we have to produce the respective output. So how the max score is getting utilized and how spillage happens in the join process is also going to talk about. So let's say we have two input file, right? Input file 1 and input file, and there is an common key wherein we are going to join the data based on that common key. Okay. Okay. And this is unused 0 and unused 1, then the output file. So this is a simple configuration basically. So what we need to know is like when the max score is going to utilize, and what is the amount we shall configure for the max score in unsorted data in memory join is like our processing is happening in optimized way. Okay. So let's understand the algorithm behind actually the join process. So we know that there is a driving input and non-driving input port, right? So this is our driving data. Okay? Driving in. So this port is we need to configure as a driving port, and this is non-driving port. Okay, or non-driving data. So what happens is we have kind of max score, right? So for this, let's say some max score we have configured max score. So what happens is in join process, first of all, it will read all the non-driving data into the max score. So max score is directly proportional to the size of the non-driving data. Size in not number of records, size in number of bytes. What is the total number of bytes in the non-driving port? Okay, total number of bytes, not like in between or half and all those things. Everything. So everything is going to be read into the max core memory, in memory, because it's a primary memory allocated for a join process, right? Then what happens is, then it will try to read the data from the driving port, and it will find, let's say K1 is received, and we find that there is a match in memory in the non-driving data, and it will produce the output. And if nothing is matched, then what it happens is, depending upon the type of join, if it is a inner join, so what happens is it is going to be unused 1, unused 0, because it is a driving port, right? So and from the driving port it doesn't find match in memory data of the non-driving data, right? So then it will go to unused 0. Otherwise, it will find the join. If the driving data finds the match into the whatever is there in memory in the non-driving data, it will produce the output. So it happens. Okay, as long as, so in this case is like all the non-driving data is successfully got placed in max score, right? Max score is well beyond that amount of size, right, of the non-driving data. So this is there is no spillage happens in that case, right? Everything is well good, and we have non-driving all the data in non-driving data into the max score in memory. Non-driving data comes, if it is able to find the join, produce the output. If it doesn't find, based on the join type, whether it is a left outer, right outer, or outer join, or full outer join, based on that it will produce the output, right? It may join with the null, right? So it happens. Now what happens is, let's say we have a non-driving data. The total number of the size of the non-driving data is going to beyond the max score amount. So what happens is, at that point in time, you know there will be a spillage happens. Okay, so the data from the non-driving, right? So some of will be there in the max score, and rest of those will be created, will be placed into the spilled area. Okay, it will non-driving spilled data. Let's say this is non-driving spilled area, and it will get the temporary file there based on the key, partitioned file, partitioned based on the key. So let's say for certain key, with it is not able to hold into the main memory, but it is going to, let's say, K1, K2, K3, K4, all those files getting, partitioned file is getting created. Okay. Maybe there could be multiple Ks in one temporary file, right? So what happens is it is creating the partition file based on key, because we know the key, so it is clever enough to produce the file based on the keys, right? Partition file. So this is how happens, and all the data from the non-driving input is getting read, and some of them which is not able to put into the max core will be placed into the disk, or that is called temporary file in the disk, and it is called a non-spilled data area. Okay. Now, after reading everything from the non-driving port, what happens is it is starts reading the driving data. So driving port is getting read one by one. So it will first check in the in memory, right, max core area, whether the join happens. If it is happens, then well and good, produce the output. Okay. But what else? What if there is a key in the driving data, but it is not able to find in the in memory? So in that case, what happens is, so if that, it cannot assume that there will not be any join, right? Because there is a data which is there in the disk. For the non-driving data, there is a data in the disk. So what happens is join algorithm puts this data into the disk as well. So driving data is also getting placed into the disk area. Okay. So all those data which, all those driving data for which, all those keys which, you know, it is not there in the in memory X core, all those keys will be placed into the these temporary file. Okay. This is also getting placed as partitioned. Okay. So this is how happens. So all the driving data is also getting read, and some of them is find join and processed. Some of them which are not able to find the join, it is going to be placed into the disk. Now what happens is finally all those things will come into play, right? All the non-driving data is going to be read, and then same thing happens actually. So this is another file, this is another file. So non-driving is placed into the max core, and then after driving is getting read. If it is find join, then produce the output. Otherwise, spilled into a disk. So what happens is, if join thinks that we are going into the multiple iteration of this kind of spillage of both the ports, what happens is, if join will think intelligently that what is the size of the data, right, and it will spill everything into the disk irrespective of driving or non-driving at the first place itself. It won't use the max core, it just will drop into the disk and then try to produce the output. So this is the kind of, this also happens, right? In that case, there will be all the data will be spilled to disk for both the ports. So this is the rarest of the rare case, kind of rare case, wherein it thinks that there will be a multiple iteration of this thing, right? Spilling and in memory processing. In that case, it will produce the output. I mean, it will for the first while reading, itself it decides that let's put the everything into the disk and then try to join. Okay, so to configure the max core, we need to think of the non-driving data. Okay, and we have to decide the max core which is suitable for the size of the non-driving data, and uh, and then we'll left to the join process to decide, right? So this is the way the algorithm works, and the max score is getting decided and the spillage happens. Okay. So the decision of the spillage is depending upon the size of the non-driving data, and the number of bytes to be spilled is going to be based on, it could be based on the size of both driving or non-driving, right? So thank you so much.